What actually happens when immutable code makes an irreversible mistake? It's a pretty wild question when you really stop to think about it. Welcome to this explainer. Today, we are diving deep into the seriously alluring myth of perfect, trustless systems. For years now, this utopian vision has totally captivated the digital world. This idea that we could somehow just replace the messy, subjective nature of human courts and legal systems with pure, unyielding mathematics. But, as we're about to see, the real world has a funny habit of breaking perfect math.
Our main focus today is on the fallacy of code is law. We're going to dismantle this utopian idea that software can entirely replace human governance, and more importantly, we'll explore the strict rigidity of standard blockchain architecture. We need to understand exactly why this concept completely falls apart in the real world when malicious actors exploit immutable smart contract code to break off chain promises and somehow walk away without any legal repercussions. It's a massive issue, but the industry is actively rebuilding digital trust to fix it.
All right, here's our roadmap for this explainer. 1. The code is law myth. 2. The smart contract trilemma. 3. Exploits and hard forks. 4. The limits of immutability. And 5. Regulation by design. Let's jump right in. Part 1. The code is law myth, the dream of trustless systems. To really grasp where we are today, we first have to understand the cyber-libertarian dream that kicked this whole thing off. The foundation of this dream is a concept called lex cryptographia. Basically, this defines rules arising from relationships, behavior, and governance that are codified directly onto blockchains. Theoretically, this enables an order without law. The idea spread like wildfire because it was just so incredibly appealing. Blockchain code was genuinely believed to be this unchangeable, supreme legal authority. It promised us a world where self-executing smart contracts would seamlessly manage our affairs without the need for lawyers, judges, or traditional enforcement. No red tape, just code. Moving into part 2, the smart contract trilemma, where the myth breaks down. Okay, so what happens when that brilliant theory meets the harsh reality of software architecture? Well, the myth quickly breaks down into 4 critical vulnerabilities. First up, human error in coding. A simple typo? Boom, absolutely catastrophic. Then there's the black box effect. This is where the code is practically illegible to non-experts, completely masking what it's actually doing. Third, we have the mistranslation of human intent into code. Think about how much nuance is in a traditional contract that often gets totally lost in rigid programming logic. And finally, extreme rigidity. Because smart contracts are immutable, once they are deployed, any bug or unintended consequence is just stuck there indefinitely. You can't just call a help desk to reboot it. Early on, we kind of thought of smart contracts as simple, predictable automation, like a digital vending machine. You put in a condition, you get a predictable result. Simple enough, right? But modern decentralized finance absolutely did not stay that simple. It evolved into what is best described as a liquidator casino. It's this tangled, highly complex, multi-layered environment where a single bug doesn't just eat your dollar bill, it allows opportunistic actors to drain millions in a matter of seconds. Which brings us to part 3, exploits and hard forks, the $150 million reality check. Talk about a wake-up call. The rapid escalation of the 2016 DAO hack is literally the perfect case study for this. In April 2016, a decentralized autonomous organization, or the DAO, launched, raising an absolutely staggering $150 million. But just a few weeks later, a vulnerability was discovered in its smart contract code. And by June, a hacker had actively exploited that exact bug. They used the contract's own rigid logic against itself to systematically drain millions of dollars. Here's the crazy part. The code was doing exactly what it was programmed to do, but the outcome was fundamentally opposed to the human intent of the investors. And this right here perfectly illustrates the ultimate irony of the code is law philosophy. Faced with this massive, catastrophic theft, the community executed a hard fork. They essentially hit a giant undo button, creating a brand new version of history to return the funds, completely abandoning the original exploited chain. When the stakes were high enough, human consensus instantly overrode immutable software. It highlights a really profound friction between digital architecture and actual human justice. Section 4. The limits of immutability. Friction between code and reality. So while on-chain smart contracts are incredibly isolated and highly secure, the real danger actually lies at the boundaries. When off-chain promises, like, say, tokenizing real-world assets like real estate or gold, rely on data from the outside world, the strict rigidity of the architecture just fails. Usually, this real-world data is brought in by oracles. But because of the latency in updating that data, malicious actors can use strategies like maximal extractable value, or MEV, to front-run transactions. Basically, they exploit the immutable code to break those off-chain promises, extracting massive value before the smart contract even knows the true updated price of the asset. And the worst part? They often do this without facing any legal repercussions whatsoever. So, the crucial takeaway here is captured beautifully in this quote from our source material. Hard-edged, cryptographically secured code can never fully encompass human intentions. Traditional human law is dynamic, right? It considers context, intent, and nuance. Deterministic software, by its very nature, absolutely struggles to translate those dynamic nuances. When you try to automate all the messy complexities of the real world into rigid code, you inevitably create loopholes the bad actors will find and exploit, every single time. Let's move to our final section, Part 5, Regulation by Design, the Practical Pivot. Instead of stubbornly clinging to that blind immutability, the industry is doing something really fascinating. They are modernizing digital trust. We are actually seeing a major paradigm shift from code is law to law is code. So what does that mean in plain English? It means prioritizing pre-embedded compliance over traditional post hoc enforcement. Rather than chasing bad actors across international borders after a theft has already happened, the rules are built in from the start. A fantastic example of this is the token container model from the Liechtenstein Blockchain Act. In this model, a digital token legally acts as a container for real-world rights. It's all about integrating policy as code, transforming discrete legal decisions into continuous, autonomous rule sets. And how is this practically achieved on a technical level? Through specific, highly structured technological standards like ERC 3643, which is also known as the T-Rex protocol. Now, this isn't the Wild West anymore. This is an institutional-grade security token standard. Unlike early, permissionless utility tokens, ERC 3643 provides interfaces for the management and completely compliant transfer of tokens. It relies on a fully automated on-chain validator system that leverages on-chain identities. This ensures that only eligible, verified investors can actually hold or transfer the assets. Let's actually walk through the mechanics of how this actively prevents unauthorized transfers before they ever even hit the blockchain. Think of it like a digital bouncer. First, the protocol checks an identity registry to ensure the user has verified credentials, meaning they've passed KYC and AML checks. Next, it validates the global token rules via a dedicated compliance smart contract, checking things like, say, the maximum number of investors allowed per country. And finally, it executes a function called can transfer. If all the rules are met, great, the transaction finalizes. But if a malicious actor tries to bypass compliance, or if a sanctioned address attempts a transfer, can transfer simply blocks the transaction right there at the protocol level. No exceptions. This shift to policy as code is absolutely vital for the safety of your digital investments. It protects users without sacrificing the incredible efficiency that makes blockchain technology so powerful in the first place. By directly integrating real-world legal realities into the smart contracts, we finally stop relying on the deeply flawed premise that rigid code will flawlessly govern human behavior. Instead, we're using code to actually enforce the well-established laws and compliance frameworks that our society already relies on every single day. Which leaves us with this final, provocative thought to wrap up our explainer today. Does the ultimate future of digital trust lie in the endless pursuit of perfect, isolated code, or does it lie in perfectly coded laws that finally bridge the gap between digital efficiency and human reality? As we've seen today, the shift toward regulation by design strongly suggests the latter is not just necessary, it's inevitable. Thank you so much for joining me to explore the evolution of digital trust. Keep questioning, keep learning, and I will see you next time.